Hello everyone, I'm Mumtahina Riza, a PhD candidate at University of Central Florida. My research focuses on soil biogeochemistry, especially the stable carbon pool, which is called mineral associated organic matter or MOM. So in my poster, I will discuss about the existing and potential indicators for soil health in cultivated histosols. So here I would like to highlight the cultivated histosols. So at first I would like to show what is histosols. So histosols is the organic rich soils where there are at least 20 to 30% organic matter present in the upper layer of the 40 centimeter of the soil. And generally these histosols or the organic rich soils are formed in wetland environment, and it takes a very long time, around 4,000 years. Actually it comprises with the decomposed hydrophytic vegetation, and it remains over the limestone depression. So if we see here the Everglades where my research project is going on, Everglades is a unique wetland ecosystem, but Everglades agricultural area is here where wetlands have been converted into agricultural land, and currently it's used for agricultural purpose. Mostly the sugarcane and other vegetables and rice are being produced, but due to the drainage of agriculture there is a huge loss of soil carbon and subsidence and lots of carbon emissions. So the carbon emissions and the soil loss we can see here, which is alarming. In 1924, soil level was here, and 2023 soil level is here. So during the last 100 years, there is a huge elevation loss due to soil mineralization, oxidation, and the average subsidence during 2010 to 19 was 0.62 centimeter per year, and the recent data for modeling shows that only 3 feet soil is left in beneath the soil. So my research goal is to protect the remaining ES soil. If we would like to show the soil mineralization and elevation, we see here. So organic matter is present in the soil, but when this organic matter reacts with the microbes, so in presence of oxygen, microbes consume the organic matter and produces carbon dioxide, which is called mineralization or soil oxidation. And due to this oxidation, we see the soil level actually losses, and this is called soil subsidence. And due to the subsidence in Everglades agricultural area, there is loss of soil carbon, disruption of the natural hydrology, and ultimately there is a degradation of water quality. So extensive modification for agriculture has been done in Everglades agricultural area. So what we can do, so MOM or mineral associated organic matter, which is a stable carbon pool, which is a promising avenue to protect the soil. If we see here for MOM, the lifetime actually it's very long, even century to millennia. It can stay in the soil environment without actually it has very limited susceptibility for the changing environment, and it can stay for a longer time in the environment. So that is called the stable or uh, stable carbon pool. But POM or the particular organic matter, which is the level carbon pool, and is a very fast cycling pool, and the carbon to nitrogen ratio is lower. So in the objective or goal of my study is to evaluate the stability of the soil carbon pools in the remaining AS soil and measure the different soil health indicators in cultivated histosols. So I have collected soil samples into three depths: 0 to 15, 15 to 30, and 30 to 45 centimeter. And there are three profile depth also, which is mentioned here: shallow, medium, and deep. So which are the soil carbon pools which I have measured? These are called POXY, which is the active carbon pool, which is easily accessible by microbes and the least stable, and POM, particulate organic matter, has the low protection, and aggregates, these are stable but these have physical protection, and MOM, this is the most stable carbon pool. In lab analysis, I have measured lots of soil health indicators which are physical and chemical. So pH, moisture content, organic matter, total carbon, organic C. I will show this in my result slides. So results shows that EA soils, which is the cultivated histosols, though it is organic rich, but these soils are used for agriculture. That's why we are defining this as a cultivated histosols. So only 2% clay is present and 15% is silt. And we see here the majority of the soil is organic matter, and there are some fine and coarse sand particles are also present in EA soils. So if we look into the physical and chemical soil health indicators, so we see here 0 to 45 centimeter depth, there was no significant statistical variation for these physical and chemical properties. And if we look at the distribution of the carbon pools, which is alarming because only around 1% soil is protected as a MOM, the stable carbon pool, and the rest are POM or the labile carbon pool. And if we look at the epoxy, which is very biologically accessible pool, it's also very high, around 28 gram per kg, which is uh, actually higher, substantially higher compared to the agricultural soils. And water stable aggregates data show that it's dominated by large particles, which is greater than 2 millimeter, but the clay and silt size, which stays here less than 53 and greater than 53 micrometer fraction, which contribute to the formation of MOM, which is very few, around 10%. So ESL has some physical protection as aggregates, but these are only physical protection, but the physical chemical protection is very lower here. So, as a discussion, soil health indicators were uniform across the depth and total soil profile thickness, and physical protection and physicochemical protection were comparatively very minimal in cultivated histosols, and labile carbon pool dominated the cultivated histosols, and therefore MAOM or mineral associated organic matter may be a potential indicator for the soil stability in organic rich soil. So I would like to acknowledge our funder agency USDA, my lab mates, Aquatic Biochemistry Lab, our collaborators for the project, and obviously Soil Health Institute for giving me the opportunity to present my work here. And thank you everyone for listening to my research, and I would like to take any feedback and feel free to reach out to us. This is my email address and QR code is for our lab. And thanks again. Okay, keep in touch and get connected. Thank you.